Good afternoon, everybody. I stand between you and your weekend, so I'm going to talk quite quickly about what I have been doing. I will start by thanking Stefan for organising this and for inviting me to give this talk. I am going to talk about some of the work that we do in my group and some of the things that we've been involved with in thinking about biosecurity and pandemic preparedness over the last couple of years and before COVID actually started. Thank you, Stefan. As I said, I'm going to talk fast. So I'm also going to weave through this talk a story that I learned when I was at primary school that sort of I got very engaged with when I was at primary school that actually I think has very much relevance today. And that's going to come in 3 parts through the talk, and I'll sort of get to that as I go through the talk. So in 2018, the UK government launched its biosecurity strategy. And in 2019, they would put that out for consultation in the summer of 2019. And in my group, we got together a bunch of stakeholders who were involved in this, and to bring them together to think about how we should respond to the UK's this response. And from that response, we came up with, or within that response, there are sort of 4 themes that we got to think about in terms of planning out pandemics and preparing for pandemics. And I'm going to sort of like sketch through some of those approaches that we've taken and thinking about how we engage with stakeholders and how that's really important in the sorts of things that we do. So one of the first things that we want to do is to define what we mean by an epidemic or a pandemic. And I'm sort of going to appeal a little bit to Adina's talk this morning and put some pragmatism into that, actually thinking about how we use that approach to think of how we use that approach to actually put models, and I'm going to, because I'm doing mathematics, into sort of the mathematics a bit of that, and how we think about building models to help us inform and educate people about sorts of things. But the first thing we want to be able to do is to appeal to some semantics and some optics about how we can define what we mean by a pandemic. And this is some of the things that we have thought about in the group. We've actually put some quantification onto some of those sorts of things. So thinking about how wide geographic spread is that the things are that the places that are experiencing a disease are contiguous, are they separate? How is that disease moving? How transmissible is that disease? How infectious is that disease? How contagious is that disease? All of those sorts of things matter when we're thinking about pandemics. And pandemics are not new. We've been experiencing them forever, and the pictures on the side just illustrate that. So the top one is the plague of Athens that ravaged Greece in about 400 BC. The middle picture is about plague, and the last picture is about Spanish flu. And we still experience that COVID is sort of educated us a little bit more about pandemics, but they're not new, and we've been experiencing them forever. And really thinking about how we prepare for those has been really, really important. And the bottom one is what we've been really focused on, is how are we able to develop the sorts of skills and the communications and the models that we do to actually think about when we identify novel pathogens. So, as I said, I'm going to introduce a little story to you. And some of you, maybe all of you, are familiar with this sort of story. And it's centred very close to where I grew up as a kid, in northern England, in Derbyshire. And it's centred around the church in this little village called Eyam. And it was thinking about and it's set back about 350 years ago when the plague was ravaging London and England. And really thinking about how the church was actually instrumental in thinking about how to control this pandemic. I'm going to leave it like that. I'm going to fill you in as we go through the talk on little bits of that story. So the first thing we want to do when we're thinking about sort of like preparing and thinking about pandemics is really to get an understanding. And that understanding comes with thinking about how we can evaluate risk and thinking about how we define a risk of whatever that might be. And as Stefan outlined, in some of the other bits of work that I've been involved with, identifying risk and how we quantify that has been super important. So we can think of it as a little schematic. We can think of it in terms of actually we want to think about what we mean at the top, which is identifying what that actual risk is. And then there are 2 things on the left-hand side, exposure to that risk or that hazard as we call it, characterizing that hazard, and then thinking about how we're exposed to that particular hazard. And each one of those actually involves very detailed conversations that go beyond what I've written up here about mathematical modelling and actually involve us engaging with stakeholders. And the work that we've been involved with has been thinking about genetic biotech and thinking about how do we roll out particular biotechnologies and what are the risks associated with that. And it turns out that actually identifying what we care about at the very top is actually crucial to actually then being able to unravel how we characterize that hazard and how we characterize the exposure to that hazard. But actually quantifying risk becomes very much a mathematical approach. So very much in what was being discussed earlier this morning was actually we're thinking about engaging with broad stakeholders and building a model to be able to identify what that risk and how we quantify those sorts of risks might be. Just to put a little bit of detail into that, on the right-hand side of this slide, you can see the sorts of the influenza pandemics that have ravaged us since somewhere like, what does that say, sort of like maybe the maybe the late 19th century. Those are the influenza pandemics that we've experienced. And in order to be able to, and the most recent one was about 10, 12 years ago, where something like maybe a billion people suffered from this particular influenza. And actually, compared to what we've experienced over the last couple of years, the actual media attention and the focus on this was actually quite small. But actually, it's had quite a massive impact in terms of the spread of this particular disease. And in order to sort of like understand this, in order to get a rich understanding of these, and again, heard quite a bit about this earlier this afternoon, is actually developing sort of mathematical models to be able to help us inform. And what we want to be able to do is to be able to understand that data. We want to be able to understand that data to be able to provide information and communicate what the disease spread is going to be like. And the red lines just illustrate predictions from different models about how severe that infection is going to be and how long it might last. So the peak telling you how infection it's going to be, and the spread telling you how long it's going to last. And with that sort of information, we can sort of get to a point where we can sort of engage with wider communities and have conversations about how we're able to understand these sorts of infections. Going back to my primary school story, this is William Mopson. He was rector of the parish church, St. Lawrence Church in Eyam, in 1665. And in 1665, the plague spread from London to Eyam in carpet or cloth that the local tailor had ordered. And the village, and during that time, plague is spread by fleas. This cloth was full of fleas, and the tailor and his family succumbed to that disease. There were about 800 people in this little village, and over the course of the couple of years of which it was spreading through him, about 200 people of them succumbed to that disease. So in that 350 years ago, it was quite scary because we didn't have all of this understanding of about the knowledge that we have today about how infectious diseases spread. So the villagers turned to the rector for guidance about how to deal with this infection. So William Mopson and other clergy had to think about how to deal with this sort of infection. So it's really thinking about how understanding what this situation was causing and really trying to think about how to prevent it sort of spreading further. That's the second part of my story. I'll get to the end of that. So in this biosecurity strategy, we have to think about preventing. How are we actually going to prevent pandemics? And what are going to be the things that we need to have in place in order to sort of plan for sorts of what the WHO called disease X? And there are lots of things that we can do. So one of the things, obviously, you're now getting the impression of the sorts of things we do. We build mathematical models because those help us. We can think about building diagnostic tests because those might help us. We can think about, once we have those in place, developing right communication strategies. And we've just heard how that has been rolled out successfully through Romania. We can think about how we can use modern technologies. And again, we've just heard about how those have been widely used in Romania to actually think about communicating difficult issues to, across communities. But it goes much further than that. What we've actually focused on is stage 3 in thinking about how we prevent pandemics. What we've focused on is thinking about how we can communicate person-to-person spread. But actually thinking about pandemics and preparing for pandemics is much, much broader than that. And it starts at the very top, which actually is thinking about the social, economic, and ecological environments in which these sorts of pathogens can emerge from. And again, that doesn't prevent us thinking about how to communicate that sort of understanding and engaging with broader stakeholder groups about the way that we are running our lives and developing our economies and thinking about the social infrastructures that we have in place. The second one is about, well, thinking about more about how we interact with our environment. It's very ecological and very environmental. But again, it's critically important in thinking about how we prepare and think about preventing pandemics. So there's lots and lots of sort of opportunities here where we could be a lot better than we've learned over the last couple of years about how important it is to have this sort of stakeholder engagement. One of the themes that came out of the workshop that we were running, engaging with stakeholders about responding to the UK's biosecurity strategy, was thinking about this prevention, thinking about biologic risks, because we've only got to look at the news, the contemporary news, to realise what risks they might propose to the Western world. And the WHO have some particular thinking about this, but one of the really critical things is having national agencies, broad national agencies that are involved in thinking about biologic threats. This graph just illustrates threat against time. The red triangle just illustrates how important biological threats of thought or thinking are becoming in the 21st century. So really thinking about how we build infrastructures to be able to deal with this, national agencies, international agencies that actually consider and counter these threats is really, really, really important. And again, it involves having a broad agenda and broad stakeholder engagement in thinking about how to develop this going forward. And this was one of the recommendations that we put out into our thinking on this. Sorry. The third theme in thinking about how you think about pandemics is being able to detect them. And we've all got very familiar with this over the last couple of years in thinking about actually how do we detect a pandemic, how do we detect a novel infection, and how do we respond to that. So again, you're getting the theme that actually mathematical models are going to be critically important in this, and thinking about how we can use different interventions to actually think about what the consequences are for being able to detect novel pathogens is really important. So one of the things that we've done is we've developed a little mathematical model thinking about how if there are people infected, there are people who are when that infection arises, they are identified rapidly and quarantined in some way, and thinking about what the consequences of that might be. So it's the what-if scenario. What if a novel disease emerges, like disease X, and we're able to rapidly identify that? How then, what would be the consequences of that? And being able to have that information allows us to be able to communicate what the outcomes might be. But before we get to that, we have to have these sorts of things, and these sorts of things being diagnostic tests. And those diagnostic tests raise a considerable amount of moral and ethical dilemmas that we need to deal with. So we're all very familiar with lateral flow tests. We're all very familiar with PCR type tests for being able to detect COVID. But actually, all those tests and the data that's collected from those tests has to be dealt with in some way, and being able to appropriately inform people about what's happening to their data, particularly if it's test data, particularly if it's genomic data, requires us, again, to have broader stakeholder engagement with this. So while we're able to use all of these modern methods of being able to sequence pathogens and being able to sequence that information from people, it also involves us having to have proper engagement with communities. So what those models tell us, what they give us, is lots of very good information about what the consequences will be of those diagnostic tests. And again, that just helps us inform and have appropriate conversations about when to roll out those tests, what those tests might do, what will happen if we didn't have those tests. So let's take the graph on the right, basically. That says just the proportion of people infected through time. The blue line on the graph on the far left tells us what would happen in the absence of any test. So we basically see a massive spike in infections. It fades out after 200 days. So that's a scenario. If we were able to develop a diagnostic test, a rapid diagnostic test, we can get one of these other type curves coming out. And the consequences are that if we're able to roll tests out in different ways, and the way that those tests are delivered could give rise to different types of patterns through this novel emerging infection. So that tells us that while that might not be accurate, it gives us the general outcome about how we might be able to deal with a novel emerging infection. It gives us a platform on which we're able to have conversations with people about thinking about being able to use these tests to roll them out and think about how to control infections. We had a little bit of an opportunity to sort of like test some of these ideas very early on in the pandemic a couple of years ago, where we were able to engage with a broader community, and by that actually I mean Oxford, and engage with about 3,000 people in being able to roll out some of these very early diagnostic tests, rolling out some of these some of these molecular methods that are available for sequencing novel pathogens, and really thinking about how to do and we've got obviously ongoing science behind that's really important. But one of the things that those things I've just mentioned about engaging with the ethics on that has been really important. Having conversations with groups of people and engaging groups of people in this activity has been really important, and has been able to achieve. This is a very small study, but being able to achieve this over a short time scale involved us engaging with a range of stakeholders. So the final part of thinking about planning for pandemics and pandemic preparedness is thinking about how we respond to an emerging infection. Now, again, we're all pretty familiar with this sort of thing. So having non-pharmaceutical based interventions, not vaccines, so wearing masks, social distancing, thinking about lockdowns, thinking about vaccines, all of those things, all those public health measures involve us having appropriate communication. And one of the best studies I've seen is this one that was published in late 2020, which was thinking about the public health measures and the behavioral changes and the behavioral interventions that were made in Hong Kong. So the middle part of the picture shows the emergence of COVID infections in Hong Kong, and what we see basically in the bars, so things, the light blue bars at the box to the top are the sorts of things that were put in place: travel restrictions, wearing masks, lockdowns, and the big blue bar at the bottom just shows the percentage of the population that they believe were engaged in that. And it just demonstrates that actually how important that is, not just recording the number of infections, but actually thinking about the use of mask wearing, thinking about the avoidance of crowds, thinking about travel restrictions, lockdowns. It's really important in thinking, how to focus the mind of the public in achieving a public health outcome to limit the number of infections as they start to grow. So we did some similar sort of things in thinking about how to respond to this, and thinking about how you develop responses to this, thinking, well, we're in a lockdown scenario, how then, and what would be the strategy to release communities, people, whatever you might think of, back into sort of like normal work or normal economic function. So again, we can build a sort of like framework for thinking about that. We've got a disease. We've got people moving through different classes of being susceptible or infected by COVID, but they're some sort of, there are a group of people, a large group of people that may be actually in sort of quarantine state or lockdown state where they have reduced levels of potentially spreading that sort of infection. And the question we want to ask is, what happens if you impose a lockdown in that situation, and what would it do to the size of the COVID peak that might be coming? So this was, we took this work in the start of the autumn of 2020. So the top graph shows the sort of number of people infected through time. The little dashed graph shows that on that top graph, the little dashed curve shows what would happen if we didn't do anything. If there was no lockdown, what would happen to the size of the epidemic that was about to hit us in late 2020, early 2021. And then what we did is we played out some scenarios again, saying, well, actually, if you did this level of lockdown, this is what would happen to the size of the epidemic, or when the epidemic would peak. And the harder you lock down, the longer it would take for that infection to emerge. So that's what these repeated curves show on the top graph, that the harder we lock down, the more the later you could delay the peak of infection into sort of like mid-2021. So if you look at the data compared to this, so this is when the conversations around lockdown were thinking about little circuit breakers, short lockdowns for a period of time. So if we did a 30-day lockdown at the start of October, it would have pushed the peak of that epidemic in different ways, and the severity of that lockdown would really have it could have had important consequences for the emergence of that peak that we saw at the tail end of 2020 and early 2021. The amount of delay and in responding to the emergence of infection led us to seeing a very large peak in early 2021, and we would say, given the predictions of our model, you should have acted sooner. And again, that would have involved more appropriate and more robust communication from the people involved in that. I'm nearly done, but I'm just going to finish my story. Again, William Bobson was the rector in Eyam in the 1660s, and he was responsible for thinking about how to deal with this impending epidemic of plague that was running through this little village in Derbyshire. So what did he do? He working with his colleagues, he set up a cordon around the village. And you can go to Eyam today, and there are boundary stones where these were put, where people were not allowed to enter or leave the village during this epidemic. He cordoned off the village and prevented it spreading any further. He instigated rapid burial of those people that had unfortunately died, so that they weren't contagious. And he maybe not quite you want to do as a rector of a Church of England, he prevented mass gatherings. So 350 years ago, this gentleman had, so without the knowledge of the science that we have today, I don't know what the word is, insight, thinking that actually limiting spread by imposing lockdowns and preventing mass gatherings prevented, the whole of Eyam, those 800 people suffering from this disease, prevented the wider community from experiencing this disease. And through his actions, it's still used today as a classic study in the prevention of infectious diseases. So I grew up knowing this story. I didn't realize today that I'll be telling you guys all about it, but hey, there we go. Okay, so just to finish up, I think that obviously for thinking about early warning systems, thinking about pandemic preparedness, there's a whole sort of things that we can do in thinking about developing, responding, detecting, and preventing those sorts of infections. But without appropriate stakeholder engagement and using the information that we can generate through the sort of use of mathematical models, it isn't going to go very far. And I shall just thank a bunch of people who have been involved in this work. It's not all me people in my group, the people in bold are those that have led different aspects of the work, and the people at the bottom have supported us through some of this. And again, I'll thank Stefan, the Maths Institute, and the Ian Ramsey Centre for hosting this for today. Thank you very much.